Welcome back, everybody. Today we're going to start a new chapter of our course. We're still talking about basic descriptive statistics, but now we're going to start focusing on what we call central tendency. As we discuss central tendency, we'll learn how to compute and interpret three different measures: the mean, the median, and the mode. So they're really very straightforward. You're probably already familiar with at least two of those three. As the name implies, measures of central tendency focus on the center of a distribution. Take a look at this distribution right here. This is a histogram, and you probably recognize that it's normally distributed. So not only is it symmetrical, but it forms a shape such that most of the scores pile up right around the middle, and then we have far fewer scores that are really high and far fewer scores that are really low. Remember, this axis right here represents our data. It's our number line. And this axis right here represents our frequencies. So in this case, we had lots of students earning C's, far fewer students earning B's and A's, and far fewer students earning F's and D's. So most of the action is right around in here. Most of the students scored right around in here. And this is really the goal of central tendency. I want to be able to have one value, usually a number, to represent the entire distribution. And I'm sure you would agree that if I had to pick one number to best represent this entire distribution, it would be 70. So if your class took an exam and then you asked me, how did we do? And if I were to say, well, on average, you scored 70, that would match up with this situation very well. So frequency distribution tables and graphs do a good job of helping us to visualize the data. But now measures of central tendency are going to do a good job of describing the entire distribution using just one value. As I mentioned previously, we are going to talk about three different measures: the mean, the median, and the mode. Each one describes the center of the distribution, but each one does that in a slightly different way. We want to make sure we understand the strengths and the weaknesses of each of those different measures, and we also want to determine when is each one most appropriate. Let's start off really easy. Let's talk about the mode. The mode is probably the most simplistic measure of central tendency of the three. The mode is often abbreviated MO, and all the mode is simply the most common score. So you can look at an entire distribution of scores, and whichever score occurs most often, that's the mode. So in these examples right here, let's just assume that we're dealing with quiz scores. Students can score from 0 all the way to 9 or 10. When we look at this distribution, it looks normal, and we can see that most students were scoring a 5. So in that situation, the mode would be 5. It's really that straightforward. And in fact, in this situation, when we have a normal distribution, the mean, the median, and the mode would all be 5. But that's not always the case. Let's look at this distribution right here. Again, let's just assume we're dealing with quiz scores. You probably recognize this distribution as being somewhat negatively skewed. When a distribution is skewed, the three measures of central tendency, the mean, the median, and the mode, are likely to be different. But it's always easy to find the mode. In this situation, we just look for the peak. Here I see a peak. Of all the values, what value occurs most often in this distribution? The value of 8. So the mode would be 8. It really is that easy. But look at this distribution right here. I guess this makes things just a little bit more complicated. In this distribution, we see two peaks. We look for the peaks to find the mode. It looks like students either did well, they got the new material, they performed well, or they didn't get the material, they didn't perform well. In this situation, we actually have two modes. We would call this distribution bimodal. So one mode is 2 and one mode is 8. That's actually one flexible feature of the mode that sometimes can be seen as a drawback. Because remember what our goal was? We really wanted to find one value that best represents the entire distribution. Well, sometimes the mode can be more than one value. I'm not saying that's necessarily a bad thing. I mean, look at that data set right there. Look at that distribution. Clearly, it's a little bit goofy. I mean, students either did well or they did poorly. There's nothing in the middle. So in those situations, when the data is unusual, we wouldn't necessarily expect every measurement that we deal with to perform exactly as we'd like it to perform. Take a look at this distribution right here. Again, we see two distinct peaks. Even though those peaks aren't necessarily exactly at the same height, we would still see that distribution as bimodal. So it looks like we have a mode at 10 and a mode at 2. Some people would call this a major mode and this a minor mode. That's okay. That's just a slight distinction to help people better understand those peaks aren't at exactly the same level. You can see the mode is really very simple and to some extent simplistic, but even a simplistic measure like the mode can tell us a lot of information about our data. Take a look at this example right here. There are 2, 4, 6 people in this small little study. They were asked to remember some information. Some of that information was presented in the form of non-humorous sentences, and some of that information was presented in the form of humorous sentences. And then the researchers counted how many of those sentences they were able to remember when tested later on. In these situations, we usually compute averages, which are means, and that's what X bar represents. And here we can see, on average, people were remembering more humorous sentences than non-humorous sentences. But let's just look at the modes. The modes tell the same story. What's the most frequently occurring data point that we see when it comes to memory for non-humorous sentences? The number that I see most often is 3. The mode for the humorous sentences is 5. So even when we compare the modes, we see that humorous information seems to be easier to remember than non-humorous information. And this next bit of information is probably the most important about the mode. It's what makes it the most flexible, and it's what makes it the go-to measure in one certain instance. And it's in this instance right here, when our data is not quantitative at all. In this particular situation, people were asked, what's your favorite restaurant? Now, keep in mind the type of data we'd be collecting. We'd be collecting names of restaurants, like College Grill, George and Harry's, Luigi's. There's nothing numerical about that. There's nothing quantitative about that. We're not measuring any type of quantity. All that we're measuring are names of restaurants. So think about it for a second. If you had that data in your data set, could you compute a simple average, which we call a mean? No, you can only compute a mean when you have quantitative data, measurement data, numerical data. Could we compute a median? You're going to see once we talk about medians, no, you couldn't compute a median either because we can't order that data and find a point in the middle. That's what the median is. It's the middle point. But can we find the restaurant that's listed as a favorite more often than any other restaurant? Yes, we can. And when we look at this very simple frequency distribution table right here, we see that the most frequently occurring restaurant name that comes up is Luigi's. So Luigi's would be the modal response. It would be the most frequent response. It would be the mode. Do you notice how we've been talking about this very simple measure, the mode, for like 5 minutes or so now? This is why you need to understand you don't want to just know how to compute things. You want to understand what this measure represents, what are its strengths, what are its weaknesses, when can we use it, when can't we use it. You want to understand the background of each one of these techniques that we talk about. Once we get done talking about each one of these measures, then we'll evaluate it, and let's do that next. So here's the mode. Again, it's simply the most common score. It's the most frequently occurring data point that we see in our data set. Let's talk about some things that we like and don't like about it. Here's one thing I really don't like about it in terms of a good measurement of central tendency. It is not mathematically derived. What I mean by that is that there is no mathematical formula for computing the mode. We do not compute the mode. We just find the mode. We look at all of our data points and we find which one occurs most frequently. Because the mode is not mathematically derived, because there's not a formula for computing it, we can't expand upon it. We can't make it more sophisticated. So as a measure of central tendency, it leaves us wanting a little bit more. Here's another issue. Remember we mentioned that sometimes more than one mode may exist. That's not necessarily a horrible thing. In fact, in some ways, that's a good thing. But if my goal is to have one value to best represent an entire distribution, the mode might sometimes let me down. And check this out. If we have a lot of variability in our data, it's possible that no mode exists. Just imagine a reasonably sized classroom of like 35 students, and I might measure each one of those students based on their weight. It's possible that no weight will occur with a frequency of more than 1. In other words, it's possible that no 2 students will share the same weight. In other words, in that entire room, there will be no mode. That's most likely to occur when we're measuring something very detailed, where a variety of data points can potentially exist. Now let's talk about some things that we like about the mode. When a mode exists, it's always an actual value. And this is actually a really nice thing. Think about this. When we compute means, we often get as an answer a fractional value. And sometimes that doesn't make sense. Have you ever heard that an average family has 2.5 kids? We understand what they're trying to say with that analysis, but it really doesn't make sense because there's no family out there, unless you overthink it, with 2.5 kids. However, we might hear that the modal family has 2 kids. That means of all the families out there, listing how many kids they have, the number that comes up most frequently is 2. That makes sense. So in any data set, when a mode exists, it always is an actual value. That is not true all the time of the mean, and it is not true all the time of the median either. Here's another thing. The mode is actually very easy to compute. And in fact, you might put that word compute in quotes because we don't actually compute it, do we? We just find it. But it's easy to find. That's a good thing. It's also easy to communicate to other people. Easy is a good thing. So that gets a happy face. And here's something really important. We can compute the mode with any type of data at all, even the most simplistic type of data that you could think of. In fact, data that we measure on nominal scales. Remember, nominal scales represent just names of categories? Here we're talking about data that is categorical or qualitative. We already saw one of these examples. We had an example right here. If we're asking people, what's your favorite type of restaurant? The data that we're collecting is not quantitative. It is not measurement data. What it is categorical data or qualitative data. There are no numbers, there are no numerical meanings. However, can we look at that data? Can we look at all those restaurant names and figure out which one occurs most frequently? Of course we can. You can only do that with the mode. You can't do that with the median, and you can't do that with the mean. And because the mode is always an actual value, discrete variables work really well with the mode. Because remember, discrete variables only make sense in terms of whole entire categories. And always keep this in mind too. The mode is great for describing the shape of a distribution. Over here to the left, this distribution is unimodal. This distribution also is unimodal. It's left skewed or negatively skewed and unimodal. This is normally distributed and unimodal. This is symmetrical and it's bimodal. You see how now we have this way that we can talk about our data that allows us to be more descriptive. So if I were to tell you like, hey, your class did kind of strangely on the last exam, I found a bimodal distribution with modes at the D level and the B level, you would see this type of distribution in your mind. So in other words, the mode, because it describes the shape of a distribution, allows us to communicate information about that distribution very effectively. All right, well, there you have it. So we've just talked to you like maybe 10 minutes or so about the mode. So there must be more to it than just finding the most frequently occurring value. Make sure you understand those characteristics inside and out. The next time we get together, we're going to talk about the median, the second measure of central tendency that we'll discuss. In the meantime, be safe.